in this video, we're going to be going through parametric equations, and this is a year. We're actually in year 11 specialist maths, and it is part of the course parametric equations. But in this course, what we're going to do is, first of all, I'm going to introduce to you what a parametric equation is. I want you to also really think about this parameter. Okay, that is of course in the word parametric. And because we can have different parameters. Now, what we're going to do by the end of it is we're going to introduce what a parametric equation is, a relationship between parametric and Cartesian. Cartesian, we're thinking about René Descartes, who was a French philosopher, mathematician, and come up with a Cartesian coordinate system, of course, which means that we have x, y, don't we? Yes, so there's a relationship between these parameters and a Cartesian equation, and I'm going to go through it much. So let's just say over here we've got a function x is a function of time, and we also have y is g as a function of time. It's a different function, so we can't say f. Okay, now the variable f is called, the variable t is called the parameter. And to be honest, the most common parameters are t and theta. Okay, so t and theta, if I can get you to write that down, please. These are the most common. Yes, you can have other parameters, but I'm going to say for the most part that these are the most common. Now, what you notice is that, of course, x comes before y in the alphabet, so x and y. There's my function of t is my x, and my g of t is y. That's just sort of saying that, there you go, there's my x and there's my y. Now, the thing is, though, that they're both in terms of the parameter, which is in this case t. So because there is both as a function of t, we can actually find a relationship between those two values. And that relationship, we can basically, for example, solve for t or substitute t into one equation and then find the other. And you can have all sorts of things. You can have circles, you can have ellipses, you can have hyperbolas, you can have anything, quadratics, it could be a straight line. Now, for instance, here, I've actually seen here that we've been told that x is equal to t and y is equal to 3t squared minus t cubed. Now, by the way, can I just ask, what's the parameter in these ones that I've just ticked? The parameter is t, yes? Now, you can see here that by letting t equal 0, and I'm substituting that, so when t equals 0, what we can find is that x equals 0. And that's just substituting that into here. T equals 0, x. So when t equals 0, x is equal to t, which is also 0. Okay? And y is equal to, a little bit trickier, but it's 3 times 0 cubed minus 0, which is also 0. So, of course, this path, now t equals 0 refers to time. A lot of the time, these sort of things describe, for example, a particle, or it could describe an object. And this object, this is the starting point, isn't it? At t equals 0, it starts here. And of course, we've just found the x and y coordinates, but we haven't found a relationship between them, because you can see here that we've got this curve. Now, what does this curve look like? Sorry? It sort of looks like a parabola, but at the same time, it could be something else. It could be a sine, it could be maybe even a cubic. Like, have you seen cubics which look like this before? So we don't know what it is. We can only guess at the moment. A parabola is a pretty good guess, but my issue is this. And when we get into advanced calculus and things, and we start getting into calculus, just to me, if this was a parabola, this is the axis of symmetry, isn't it? Does it look symmetrical about the axis of symmetry? So it's actually not a parabola. Because what we're going to do is, so to do this, yes, you could do a table of values, which helps. So when t equals 1, x equals 1, and y equals 2, there's that coordinate there. You can see that. When t equals 2, x equals 2, and y equals 4, and it seems to hit a maximum there. Because then when we go to t equals 3, x equals 3, y is equal to 0. So it goes down there, and clearly what's going to happen is as the numbers increase, a cubic is more obviously going to be a much bigger value, isn't it? A cubed. We know that 4 cubed, for example, 4 cubed is equal to 64. So even though I've got a coefficient of t squared being 3, then obviously as we go along, that cube part is going to mean that it's just going to be negative, isn't it? Does that make sense? Any questions so far? So the question is, in this instance, it's possible to eliminate the parameter t to obtain a Cartesian equation in x and y alone. Substituting t equals x into this equation gives this. Now, I'm not going to just simply, that's just showing you a bit of one example. So let's do it. I want you to show you how to do the working. So x is equal to t. I'm going to label that equation 1. Okay, and then y is equal to 3 t squared minus t cubed, and I'm going to label that equation 2. Now, we need to find a relationship between y and x, which means that we need to find a new value for t. But wherever there's t, I'm going to sub 1 into 2. Does that make sense? Because wherever there's a t, I'm going to replace it with a what? With an x. 3x squared minus x cubed. There you go. We now have our Cartesian equation, and we have just turned our parametric equation into a Cartesian equation with a parameter of t. All right. Now, other parameters. Generally, a common parameter is time. However, another common parameter is theta. There are many different sketches in the Cartesian plane. Now, I'm going to do a little bit of a side note over here, because what have I said before about the unit circle? The unit circle, now I'm trying to draw a circle here by freehand, which is sort of like actually has a radius which is consistent. It's not the worst job, but it's not the greatest job either. But this is a unit circle. Let's do a really simple one. Okay. So this is the x-axis, isn't it? And this is the y-axis. And what did we say as far as the unit circle? The x-axis can be considered, Max? Cos theta, isn't it? Yeah? Okay, cos theta. And of course, the y-axis is sine theta. All right. Now let's write this out as in relation to our parameter. So x is equal to cos theta. We're just proving, we're literally proving a circle here using a parametric equation, the formula for a circle. Okay, and y is equal to sine theta. Okay. Now, we want to find a relationship between x and y. Now, it's not as easy as subbing in t. Like before we had x equals t, and we can just sub it in. That was nice and easy. But what we can say is that let's do x squared, because x squared is equal to cos squared theta, isn't it? And y squared is equal to sine squared theta. Okay, So therefore, since there's a trig relationship, which I think most of you will know, Josh, did you want to come over here just speak into the mic? What's the relationship between between cos squared theta and sine squared theta? Because if you shout it out from there, we won't be able to hear you. Okay, let's do this. I'm going to do this. I'm going to do this. Remember that, okay, this angle over here, okay, if I have this coordinate over here has cos theta, sine theta, doesn't it? Now, cos theta, what's this radius here of a unit circle? It's 1. And we know that if I did Pythagoras, this point here, this cos theta, yeah, this distance here is considered cos theta, isn't it? So using Pythagoras, since cos squared theta plus sine squared theta is equal to 1, therefore, what can we say? X squared plus y squared is equal to 1. Does this include theta in it now? No. What type of equation is this? It starts with C. It's a Cartesian, and the shape of it is a circle. So all of a sudden, we have just using x equals cos theta and y equals cos theta, we've just using our parameter, theta. So what we can say is this is a circle. Center, center 0, 0, and we can say radius of 1. Yeah. Okay, so make sure that you're making these side notes, please, because it's really important where that's coming from. Okay. Now, knowledge needs to be at your fingertips. Like when I say like cos squared theta plus sine squared theta equals 1, that needs to be at your fingertips, because year 11, have you guys been doing that in year 11 methods? Like you would use that doing trig? Yeah. If you're trying to solve a trig equation and you've been given sine and you've got to find cos, then usually you use that relationship, don't you? So, and of course, the exact values need to also be known, don't they? And do you recall what I told you yesterday? If you forgot those exact values, how you could logically get them? Yes, the good old triangle, an equilateral triangle. Okay, I'm going to draw it again because it's on YouTube now. Okay, and that triangle is an equilateral triangle, 2 by 2 by 2, which means that we'll stick with degrees at the moment. Okay, that's 60 degrees and that's 60 degrees. Whooshka, we cut it in half, which means that we're taking that right triangle over there, which means we've cut that angle in half, so that's 30 degrees. That's 30 degrees, and that's 60 degrees, and that's, of course, 90. And, of course, we've cut this 2 in half, so that's 1, and we know that that's 2. And, of course, using Pythagoras, that becomes root 3. So you could, if you've forgotten it, and, by the way, you will have tests in methods and specialists next year where you will not have a bound reference, and you need to know those. In actual fact, you need to know those. There's actually a finger rule which you can help you. Does anyone know that finger rule? I'd like you to discuss it with your teacher. Okay, it's sort of like they're all over root 2. Like 0 over root 2 is 0, and 1 over root 2 is and is like. So there's actually a rule that you can use which might help you remember it. I'm not going to go through that now because this is a YouTube video. Okay, it would take me too long. Okay, now find the Cartesian equation for the curve defined by the parametric equation is this. As you can see here, you've got t as the parameter. Okay, so you don't have something as easy as x equals t. But what I'm going to say is that usually we have a y in terms of x in a Cartesian equation. So what I'm going to say is that t is equal to x minus 2. And I'm going to call that equation 1. Okay? And y is equal to 2t minus 3. I'm going to call that equation 2. I'm going to go 1 into 2. So wherever there's a t, I'm going to replace that with an x minus 2. Please use your brackets. Okay, these silly mistakes like not using brackets and expanding brackets properly will absolutely slaughter you in terms of marks you'll lose, silly marks you'll lose in methods and specialists. Okay, so therefore that's equal to 2x minus 4 minus another 3, which is minus 7. Okay, is that our Cartesian equation? Done? Find the Cartesian equation for the curve. So we know that this curve, now later on there might be restrictions on time. We'll get to that later, okay? It might not be a full line, for example. Well, in actual fact, can you have negative time? No. So maybe, just maybe, we're just asking for the Cartesian equation for now, but maybe you're only sketching part of that line. Okay, I just wanted to make that quite clear now. Okay, so at time equals 0. Now we could do something like this. At time equals 0, x is equal to 2. That's our starting point, isn't it? And at time equals 0, y is equal to 2 times 0 minus 3, like so. So 2 minus 3 is the starting point. For some reason, I'm going to say such that t is greater than or equal to 0. That would make more sense, wouldn't it? Because there's going to be a restriction on the domain. There's going to be a restriction on the parameter. And that's when it becomes harder. And that's where students don't read the question. They don't get their highlighter out and do the domain. They make the mistakes. Okay? They deliberately write exams to trick students. Okay? So what we're going to do is we're going to draw this particle. At time equals 0, x is equal to 2 minus 3. So I'll put a little 2 there, and there's minus 3. So in actual fact, the intercept of minus 7, we could draw it like so. The Cartesian equation goes like this. Okay, but in actual fact, it starts here, doesn't it? Okay, it starts at the coordinate 2, negative 3. Now, find parametric equations for the lines through points this. Oh, that's actually another question completely. So in actual fact, now a good thing about this is that what's happening as time increases, what's happening to y? Just think about it logically. It's increasing. So why don't we I'm going to be real fancy here, and I'm going to get a purple one. I'm going to be really fancy. And what we're going to do is we're going to zoom in here, and we're starting, put your starting point there. Maybe a bit thick, okay? But what we're going to say is that's actually an arrow, okay? Time is greater than or equal to 0. In other words, that line will go on forever unless there's a restriction on time. Sometimes there is, at which we would have an endpoint, okay? So please don't use a line as thick as that, okay? I will learn from my mistakes. Now, the other question is, find parametric equations for the line through a equals 2, 3, 4, 7. Now, I've just done some hard ones for you. I've done one over here. Now, what I'm going to do is I'm going to pause this video. We've been going for a little bit now, okay? But I think, so we've been going for 19 minutes. Stop here. I want you to have a go at question B, please. 2, 1. Okay, now, just quickly with this one. A lot of students sort of struggle to get a start on this. Now, when you're given 2 points, we could consider, it says for the line. So it didn't say the curve, it said the line. So what I'm going to say is that A is equal to x1, y1, b x2, y2. So therefore the gradient is equal to y2 minus y1, which is 7 minus 3, over my run, which is 4 minus 2. So that's 4 over 2, which is equal to 2. Now, of course, we can sub any point in now. We can say that when x is equal to 4, y is equal to 7, like so. And so therefore, we know that y is equal to 2x plus c. So when x equals 4, y equals 7. So that's going to be 8 plus c. So therefore, c is equal to -1. Now, we haven't quite answered the question yet, have we? Because it says find the parametric equations, which, you know, can be a little bit confusing, because, like, how do I get parametric equation out of that? Well, what we can say is that y is equal to 2x minus 1, but let's let x equal t. So therefore, we can say that y is equal to 2t minus 1. But what else could we what else could we do? Is that, so if x is equal to t, then y is equal to 2t minus 1, isn't it? Yeah? Done. We've gone the other way, haven't we? Sometimes if we started with this, that would be nice and easy. It'd be easier, but that's slightly harder, isn't it? Okay, a little bit harder concept to do. All right. Now, recall the trig identities. Now, I just had a Year 12 Specialist Maths lecture for Term 3, and I said knowledge needs to be at your fingertips. And I asked some of my very brightest students what the double angle formula for sine 2x was, and they couldn't tell me. Even though it's on the formula sheet, they've used it over and over again. I'm telling you now, you guys need to, as soon as possible, get that committed to memory. You don't need to put it in your bound reference because it's on the formula sheet. But what I'm saying is, should you be looking at the formula sheet? No. Same thing. Should you be looking at the, should you have to draw an equilateral triangle to find the values for cos, sine, tan of 60 and 30 degrees? No. You should know that sine of 30 degrees is equal to, you can shout it out, a half. Thank you. All right. These are the things where Confucius say, knowledge at fingertips. That is what I say in my lecture. Okay, knowledge must be at your fingertips, because if you have to then reach out and turn pages and stuff, you get anxiety. Okay, all of a sudden you get anxiety. What happens when you get anxiety? You start to panic, don't you? All right, you start to panic, then you don't think clearly. Okay, knowledge at fingertips. Can I just say, I don't ever expect you to commit those to memory, ever. All right, you're wasting your time, because in the very rare occasion when you do use them, look up on the formula sheet. Okay, don't try to remember them. So that cancels out that one, cancels out that one, cancels out that one. But and in actual fact, this one would be nice to be committed to memory, but it's not used anywhere near as often. So I'm going to put a little line through this, and I'm going to say that My students that get above 37 will commit that to memory. Raw score of 37, very hard to get, but very achievable. Very achievable. If you work hard, 37 gets scaled up to 48.4. That'll be guaranteed your highest study score unless you get a study score of about, 48 or 49. Okay. And if you get above 40 in specialist maths in year 12, top 8% of the state, you will go above 50, as I've discussed with some of you and parent teachers and things, and I can have this conversation later when I'm not on YouTube. All right, now, so what is committed to memory then, ladies and gentlemen? Do you think this one here is committed to memory? Yes. Do you think this one here is committed to memory? Yes. Because later on, and do you think this one is committed to memory? Yes. And of course, if I'm asking you to remember sine 2x, then in actual fact, we needed to use this for your last test, didn't we? Remember how we said that cos, didn't we say that cos of 7 pi on 4 is equal to 2 cos squared of 7 pi on 8 minus 1. Do you remember that one? And cos of 7 pi on 4 being in the last quadrant is the same, it's positive, and that became 1 on root 2, didn't it? Yeah? And of course, that's 2 cos squared. Now we're trying to find cos squared of pi on 8. So I'm doing this really very, very quickly. So therefore, what we can say is 1 over root 2 plus 1 divided by 2 is equal to cos squared of pi on 8. Okay, that's how you solve that problem. Knowledge at the fingertips, but also it was a tricky question. It was a very tricky question, all right? But it was very gettable. Okay, we've got 10 minutes. Let's slam through these things. This is worth 2 marks. How long do you get in a VCE exam? At 1.5 minutes per mark, yeah? So three minutes. Can someone get their timer out, please? Someone time me. Okay, I want to, ready, set, now, go. X is equal to 4 sec t. Y is equal to 2 tan t. Okay, X on 4 is equal to sec t. Y on 2 is equal to tan t. Now, you've got to forgive me for how. X squared on 16 is equal to sec squared t. Y squared on 4 is equal to tan squared t. Therefore, since sec squared t minus tan squared t is equal to 1, therefore x squared on 16 minus y squared on 4 is equal to 1. Stop. How long? 45 seconds. How much time have I just bought myself in the exam? 2 minutes and 15 seconds. Knowledge beans at your fingertips. Understand? Now, this is on YouTube, so you can copy it later. Okay? It was actually on the video. Now, it says sketch the path of the particle. Ooh, 2 marks. Now, here's the deal, right? What does it say about our parameter? Okay. Yes. Time is between, can it be 0? Can it be pi on 2? No. Okay, so let's, now we know what shape is this? What shape is it? It's a hyperbola. Is it centered at 0? Okay. So it's centered at 0. Okay. Now, what is my, importantly, when x is equal to 0, what is x, by the way? What is x? X is equal to 4 sec t. Yes? So sorry, so what I'm saying is x is equal to 4 sec t. So at time is equal to 0, this is the important part. Find the starting point. See what happens. Then x is equal to 4 over cos of 0. What's cos of 0? So that's equal to 4. But that's only half of the problem, isn't it? Because as t equals 0, we need to find our Cartesian coordinates. So we've got to find y is equal to what? What is it, tan? So you'd have to look back at the page, 2 tan of t. 2 tan of t. What's tan of 0? 0? Yep. So 2 tan of 0 is equal to 0. So therefore, we have got the coordinate 4, 0. So it starts here. Okay. Now it starts here. This is the starting point. Now let's think about what is sec and what is. Now we're talking about the first quadrant, aren't we? What can you tell me about x and y in the first quadrant? Both positive. So which way is this particle going? It's going this way. Yeah. And would you agree that although this is a hyperbola, it's actually a particle that goes like this and it approaches that asymptote, but it never gets there. So in actual fact, you could draw like that. What do you think most students do? I'll draw it in red, but most students just draw the graph, don't they? So they're the ones that get 0 or 1 mark. Okay, so most students will draw this, and most students will then draw this. But in actual fact, the one thing that we haven't labelled is whenever you get something like this, to be honest, we don't even need to label that asymptote because that asymptote doesn't exist as far as this time is concerned. So to get your answer, you just need to label that coordinate, which is 4, 0. Done. Now, the asymptote's there. Yeah, you have to have the asymptote. Yeah. No. Yeah, so the asymptote is what? Y is equal to plus or minus b on ax. What's b and a? So it's equal to y equals plus a half x, isn't it? Yeah? Yes, very good. Very good. Well done. Okay, now this is actually vector calculus, but what I'm going to say is just forget about the fact that it's vector calculus. Can I have someone put their timer on? Put the timer on. Ready, set, go. Okay, the x is the I component, just like vectors, okay? Minus 4 sine of 2t. Okay, and the y is equal to 6 cos of 2t. Can everyone agree that both sine and cos do not have the same coefficient? So therefore, it's not going to be a circle. So therefore, what we're going to do is x over minus 4 is equal to sine of 2t. And we're going to say that y over 6 is equal to cos of 2t. And then what we're going to do is we're going to square them. So we're going to say x squared minus 4 squared is 16 is equal to sine squared of 2t. And y squared over 36 is equal to cos squared of 2t. Now, we can then say find the Cartesian equation for the path. So therefore we can say that we could say that x squared on 16 plus y squared on 36 is equal to 1. Since, now I explained that, cos squared of 2t plus sine squared of 2t, these show that questions you need to show clearly. If you just skip a step and you just go write the answer, well, they've asked us to find. Stop. How long did it take? 134, okay? I explained it a bit along the way though, okay? So let's continue, all right? Now, we've got to sketch the path of the particle, okay? Now, what's happened to the restriction? Time is between 0, pi and 2, which is the first quadrant. X is equal to minus 4 sine 2t. So let's do x is equal to minus 4 sine of 2t. And y is equal to, what is it, 6 cos of 2t? Is that right? So at time is equal to 0, x is equal to 0. And at time is equal to 0, y is equal to 6. Would you agree with that? Now, by the way, this is the shape of an ellipse, isn't it? What we're going to do is we're going to find out what pi on 2 is, the endpoint, and sometimes we'll find the midpoint. So at time is equal to pi on 2, x is equal to minus 4 sine of pi on 2, which is pi, which is equal to 0, and y is equal to 6 cos of pi, which is 6 times negative 1, which is negative 6. Is that right? Is that right? So if I just pi on 2, okay, let's say at t, let's do t equals pi on 4 to see which way it's going. T equals pi on 4, x is equal to what? Minus 4 sine of pi on 2, which is equal to minus 4, and at t equals pi on 4, y is equal to 6 cos of pi on 2, which is equal to 0. So halfway between, so at t equals 0, it's at y is equal to 6 and x is equal to 0. So it's actually over here. 0, 6. And which way is it going? Which way is it going? Time, it's going to the left. Minus pi on minus 4 and y is equal to 0. So it's actually going this way. Like so. Okay, we know it's the ellipse. Okay, and at time equals pi on 2, y equals minus 6. So have I just drawn a full ellipse or a half ellipse? A half ellipse. Okay, once again, label the endpoints, because if you got to label the endpoints. Does that make sense? Now, your homework is, given the fact that I've explained to you, look at this, we've got a restriction on time again. I want you to finish it. Now, thank you so much for your attention. I really appreciate the fact that you've paid attention for 38 minutes.